To use Processor Expert, we're just going to launch Kinetis Design Studio. We're going to accept the default and let it boot up. Now that it's booted up, we're going to create a new file. I'm going to go to the top left here, say New Processor Expert Project. And it's going to come up and ask us for a name. So the name that we're going to call it is RGB_LEDS, and we're going to say next. And under here we're going to the boards, we're going to choose Kinetis. We're going to say Freedom K64. Now there's other boards, but this is the one that we've got. And we're going to say next. And we're going to select Processor Expert. And we're going to say next. And we have a number of compilers here, but we're just going to leave the default GNUC compiler and say finish. And what we're working with right now is the C++ screen of the three screens. Now what we can do is, if we don't like this particular screen, we can say Window, Reset Perspective, and say yes, and we'll go back to all the defaults that it should have, which is, this is what we should basically be seeing here. Now if we just click on RGB LEDs and go to Sources and double click on main.c, we will see the standard default code, which uses code folding here for our programmer's block and other stuff. Now we don't really care about this code, because we're going to make it generate code for us by just using a graphical user interface. So let's see how that works. Now I'm just going to switch from C++ here to hardware, and what we're going to see is a graphical view of a processor sitting here, and this is what we're going to work with to actually initialize our red, green, and blue LEDs. Now with any kind of Eclipse-based IDE, if you double click on it here, it goes full screen on any of these tabs. Double click on the tab again, it goes back into the framework that it was in before. Now we're going to make our processor screen here go full screen, and we're also going to zoom in just a little bit so you can see a little better on the video. Now you can see here this is LED RGB red and blue, and down at the bottom we'll find green. So all we have to do is click and then right mouse click on here to do pin routing. And what you're going to find here is we have a number of options to come out on this particular pin. We know that port B pin 22 is what is connected to the red LED, so we're just going to say done. And the next thing we have to do is then deal with the blue LED and click, left click, then right click, pin routing, and what we're going to do is port B pin 21 and say done. And to get to the last one down here is our green LED. We're going to left click, then right click on the pin to do pin routing, and we're going to say that that's port E pin 26 and say done. Now once we've dealt with that, the next thing that we have to do is actually deal with the ports themselves. And what we're going to do is go to PTB, right mouse click, and say add component template, and we're going to say Kinetis init GPIO. Now as it's doing that, let me just go back to the full screen thing by just double clicking here. And what we're going to see is it's going to come up with some stuff here. Now, if you want to see it coming up properly and it's not, you can just double click again, left click on here, and then go to Properties. And under here you'll get this screen. So again, double click here, go to Properties, and this is the screen we're going to work with. Now if we zoom in a little closer here, one of the things you're going to notice that all of our ports here, all of our subsystems here are going to have their clocks disabled. Why are their clocks disabled? To save power. So the first thing we have to do with port B here is enable the clock. By enabling the clock, that means that this port B that's here will now be energized and be used, and it will start using a little bit of power. Now we have two pins we need, pin 21, so I'm just going to double click on that. And what we have to do then is say initialize. Now this is going to be an output pin because this pin is going to drive voltage out to the LED. So we're going to change this from its default input to output. And also if you look at the schematic, you're going to find that if it's a 0, it's going to be on to start. So we're going to put a 1 here to make sure that the LED itself is off when we first power up. Now also we're going to have to go to pin 22, same thing. We're going to say initialize. Again, we're going to make this an output, and again we want that LED to be off, so we're going to make the default output 1. Now the next thing we have to do is go to port E, so we're going to right mouse click, add component template, Kinetis init GPIO. And what we should see up here is that this should change now to port E and allow us to initialize port E. And again, if it's a little bit slow making this happen, we can just double click here with the left mouse button and then go up here, and you can see now port E is here. And again, we have to enable the clock to turn on port E. And then if you remember, it was pin 26, so we'll double click here and we're going to say initialize, and we're going to say output, and again we want the LED to start off being off. And one of the things we want to do is, if you notice up here at the top, it has a star there, which means there's been some changes made. So what we want to do is we want to say file up here, save all, and then project build all. Once it does that, it'll have everything it needs to have everything configured for us, and we haven't really done any real programming, but it has actually created programming for us. Now that we've done a save all and a build all, the next thing we want to do is actually debug our code. Let's go up to our debug screen here, and what we're going to do is go right up to the top here, and we're going to go to this little bug symbol here, and we're going to say debug configurations. So when we do that, it opens up a screen. Now of all of these things, we're going to use GDB OpenOCD debugging. So we're just going to double click here, and it's going to continue on. Now it may ask you to add certain modules at some point, and if it does, just say OK. What we want to do is to be able to peek and poke away at memory addresses, and that's not one of the standard things that is going to come out on our debug screen. So we're going to go to Window, we're going to say Show View, and down here we're going to say Memory Browser. Now we can put the memory browser anywhere, just happen to throw it up here, but you can slide it around. So let's see how that works. If you're not comfortable with IDEs such as Eclipse, you can just grab this, you can slide it over here, put it there, you can just grab the tab, slide it up here if you want, you can put it anywhere you like. So once we've got that done, what we want to do next is to actually run our code. And we're going to run it step by step. We're going to basically say step into. Right now it's doing a common init, and if we keep doing a step into, you can see that it's going down to some stuff here. Keep doing step into. Notice what it's got here, and let's just zoom in a little bit. This material that you've got here, this code that you've got here, was actually generated by the processor expert just by using that graphical view of the processor. So all this code that you see here did not exist before. Now that we understand that, let's just go up to the top here and run it and pause. By configuring things on the graphical view of the processor, what we're physically doing is changing numbers in addresses. What we're going to find is there's a GPLB port data direction register, and putting a 1 in this address will make it an output pin. Now if you remember, we did set port B pin 21 and 22 to be output pins. Now the physical address for that is 400F F054, and we're going to be looking at that shortly. Now notice that this is a 32-bit address. The first digit of the address is bit 0, 1, 2, and 3. This is 4, 5, 6, and 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and pin 21 and 22 have to be a 1. That's why we have a 6 here. Now we also said to shut it off, and what we're going to find is this particular register here has a 6 as well, where the two 1s in the same positions, 21 and 22, make sure that those red and blue LEDs are off. Now over here we have port E, which is what we have hooked up to our green LED, and the data direction register there, if we take a look, pin 26, if you do the math, 0100, that happens to be pin 26, which is an output pin, so you have to make it output so you can drive voltages out on it to make it an output pin. And then we want to shut it off, and that's why there's a 1 in this bit position here. We're going to be using the memory browser in Kinetis Design Studio to actually peek and poke around, because once these things have been initialized already for us, that they're output, and that they're shut off, we can actually turn them on just by changing these bits here and here to see that we've got red coming on, green coming on, blue, and any combinations of those just by flipping around with the bits using the memory browser. Let's take a look at our memory browser. Now the thing that we want to do is we want to put in 0x. 0x means hex address because everything under the hood is hex. We want to put 400F F000. I want to make sure our columns are set to be 4. Now that means it goes up 0, 10, 20. It's very easy to work with. But notice if we zoom in a little bit more here, we can see already that those addresses that we were talking about before, 4054 is this guy. This is 50 because they said this is two digits as an address. That's 50, 51, 52, 53. This is 54, 55, 56, 57. So when you refer to address 50, it's this whole 32 bits here. 54 is these 32 bits, and so forth. So what we find here is this is bit 21 and 22 over here being a 6 to say that these things are output, and we can see over here that these are now 6 here to say that these things are also shut off. Okay, what we can do is we can change this 6 here to be a 4, and what we see is the blue LED coming on. If we hit the left cursor and make this a 2, we can see the red coming on, and if we hit the left cursor again and make this a 0, we actually get kind of a purple color. Let's back up one more time and hit here a 6, and it'll shut both of them off. So that's how easy it is to start manipulating, and this is the output register, and this is their data direction register that we talked about before. So it's very easy to toggle these bits high and low. Now let's go down a little bit further. Let's scroll down, and what we're going to find down here is this is port E data direction register. There's the 4, and this is the one that we can now toggle this for to turn things on and off. So if I punch in a 0 here, I get the green LED coming on. If I put a 4 here, I get the green LED shutting off.